All right, today in this video we are covering 6.3, which deals with adding and subtracting rational expressions. But we're going to do this in two parts. In this video, we're going to focus on finding the LCD, and then in the second video, we'll take a look at actually adding and subtracting. Okay? All right, so 6.3. Adding, subtracting, rational expressions. So very similar to adding and subtracting numerical fractions, you do need to have the same denominators in order for you to add these rational expressions. Okay, so let's just kind of recall that when you had something like this, 3 over 8 plus 1 over 6, here the LCD is 24. Right? And so what you do here is you try to make your denominators the same, and you try to make them look like the LCD, 24. And we see here that we don't have 24. So over here, in order for you to turn this into a 24, you would have to multiply by 1 written in the form of 3 over 3, right? So multiply by 3 over 3. And that would get you a 24 in the denominator. And then over here, the 6, in order to turn that denominator into a 24, you would need to multiply by 1 written in the form of 4 over 4. Okay? And when you do that, you end up with an equivalent fraction, 9 over 24, which if you reduce that, reduces to 3 over 8. And this one over here, 4 over 24, which is an equivalent fraction to 1 over 6, because if you reduce this, it reduces to 1 over 6, right? But now they have the same denominator, and so you can go ahead and add here, and we have a total of 13 24ths. Okay, so we're going to be doing this with rational expressions as well, finding the LCD, and then figuring out if we need to multiply by anything so that they get common denominators. Okay, but before we get into adding and subtracting, what we're going to do here is we're going to focus on just finding the LCD. Okay. So finding the LCD for rational expressions. So it's not quite as easy as finding the LCD for numerical fractions. So first thing that you want to do, factor completely all denominators. Okay. All right. So if you have repeated multiplication, then use exponents. For repeated multiplication, because that's what exponents represent, right? Okay, so you use exponents for repeated multiplication, okay? And then your LCD will have all all the factors up to the highest power. This will make more sense when we look at some examples. Okay, highest power, highest exponent. Okay. All right, so let's take a look. So if I have something like this, and I have to find the LCD. Okay, suppose that I have 1 over x plus 2 squared, x minus 1. Okay, and suppose I'm going to be adding that with this, and I have x plus 2, x minus 3, and I have x minus 1 cubed. Okay, so you can think of these factors like families. Okay, and what you're going to do is you're going to find your LCD. Okay, and your LCD, it's like it's going to list the families. Okay, it's going to list the families that are in the denominators. Okay, and here's the thing: if you see the family listed here and there, you don't have to list it twice. Okay, once is plenty. Okay, so we just need to know, oh, what families are going to be there. Okay, so the x plus 2 family will be there, the x minus 1 family will be there, and the x minus 3 family will be there. Okay, once you list all of the families that are going to be there, then you take a look and see if you have any exponents. Okay, and if you do, you're going to use the highest exponent for that family. Okay, so here's an exponent for the x plus 2 family. Okay, and this one, it's understood to be 1, right? So you take the higher of the two. 1 or 2. Exponent 2 or exponent 1. Okay, 2 is the higher, so you're going to use that. X minus 1 has power 1 and power 3, right? So we're going to take power 3. And then x minus 3 is only power 1. We don't see any others. So this here would be your LCD. Okay? Again, let me stress that you first list all of the families, okay, that are in the denominator. And you don't have to list it twice because it shows up here and here. Just list it once. Okay? If you don't see any exponents, you shouldn't see any exponents in your LCD. Okay? But that's why here, this step, when you factor, step 2, use exponents for repeated multiplication. So when you factor, don't leave it as x plus 2 times x plus 2, right? That's repeated multiplication. Instead of writing it as x plus 2, make sure you use the exponent so that when you're figuring out the LCD, that you see that exponent too. If you leave it as x plus 2 times x plus 2, it's hard to spot that exponent. Okay? All right, let's try another one. All right. Suppose that I have this 1 over x plus 2 plus 2 over x plus 3. Okay? Your LCD. So let's list the families that are going to be there. So the x plus 2 family will be there. The x plus 3 family will be there. I don't see any exponents, so I shouldn't see any exponents here. And we are done. Okay. let's take a look at this one. 1 over x plus 1 minus 2 over x plus 1 squared. Okay, so everything's already factored for us, so we don't have to do any factoring yet. Okay, so our LCD here is going to be, okay, again, start with listing the families. So I see the family x plus 1. I don't have to write it twice. Listing it once covers both. Okay, and then I do see an exponent, 2. Okay, this one has exponent 1. We just don't ever write it. This one has exponent 2. So I use the higher exponent. And that would be it. Okay. Let's take a look at this one. 1 over x minus 2, x plus 1. So I'm having these in factored form already for you, but normally you would have to factor them. Okay? All right, but I want you to practice finding the LCD without getting hung up on the factoring part. Okay, so we're going to go ahead and list the families that are there. Okay, so we see an x minus 2, and we see an x plus 1. Again, you don't have to list that family twice just because you see them. Okay, just list the families that are going to be there, that are represented. Okay. Okay. No exponents are here, so you shouldn't see any exponents there. So we are done. Okay. This does not mean x plus 1 squared because this is not multiplication. This is not repeated multiplication. This is multiplication. This is not. Okay. And we use exponents for multiplication, repeated multiplication. Okay, so let's take a look at this one. 1 over x minus 2 squared, x plus 3, minus 2 over x minus 2, x plus 1. Okay, everything's factored. So when we do our LCD, we list the families. Okay, so all the families are clear. We see x minus 2. We see the x minus 2 factor. We see the x plus 3 factor. And we see the x plus 1 factor. Okay? Those are all the families that are here in the denominators. Okay? We see an x minus 2. We see an x plus 3. And we see x plus 1. Okay? Exponents. We see one right here. Exponent 2 on x minus 2. And that's the highest exponent for x minus 2. So that is the LCD right there. Okay? All right, let's take a look at this one. Suppose you have 1 over 5 parentheses x minus 4 plus 2 over 15 x plus 1. Okay, so again, we list our factors here. Okay, so when you have numbers here, then you treat it just like a numerical fraction and find the LCD between the numbers. So between 5 and 15, the LCD would be 15. Okay, and then you can go ahead and continue on with your family of factors. Okay, so we see the family x minus 4, and we see the family x plus 1. And we don't see any exponents, so this is our LCD. Okay. All right. And let's take a look at this one over here. All right, suppose that I have this here, 1 over x squared minus 3x minus 2 over x squared, x cubed plus 2x squared. Okay. So this time I did not factor it for you, so you will need to do that. Okay, so looking over here, this is a common factor. They have a common factor, x. So we get x minus 3. Okay, and then over here, this is also common factoring. They have common factor x squared. So I'll factor out the x squared, and I will be left with x plus 2. Okay. All right, so my LCD. So I see the family x, and I see the family x minus 3, and I see the family x plus 2. As far as exponents go, I see x squared. Okay. No other exponents, so this is my final answer. Okay. Let's do one more. All right, so suppose that you have this 1 over x squared minus 1 plus 2 over x squared plus 2x plus 1. Okay, again, these are not factored, so you'll need to factor them. We have perfect squares over here, so this is x plus 1, x minus 1. This here, we need to make x squared, so x times x to make x squared. The signs have to be the same to make positive. This tells us they will both be positive. And there's only one way to make one. Okay, but this is what I'm talking about right here. This is a repeated multiplication. So here, don't leave it like that, but go ahead and use your exponents to represent this repeated multiplication so that when you find your LCD, you can spot the exponent. Okay? All right, so the families that we see are x plus 1 and x minus 1. No need to write x plus 1 again. And the exponents that we see, square. So that would be our LCD. Okay. All right. If you have any questions about how to find the LCD, make sure you text me or email me. Okay. So stay tuned for part 2, where we actually take the LCD and then we go ahead and add and subtract these rational expressions.